Now the last part of the topic actually teaches you how to calculate the energy changes for a reaction. So how to calculate that delta H value that we've been talking about. So I'll give you the equation and then we'll have a look in a bit more detail at it. So delta H, the energy change for the reaction, is equal to the bond breaking energy. So the energy required to break all the bonds, and then minus the bond making energy, so minus the energy released when we make all of the new bonds. What I'm going to do now is I'm going to just show you how that equation is derived. You don't necessarily need to know how it's derived, but I think it's helpful. So here's our exothermic energy profile. There's time, there's energy. The products have got less energy than the reactants, and delta H is that value there. So in order to calculate that value, what we do is we add up all the energy that we would need in order to break the bonds, and then we minus all of the energy released when making the bonds. And if we add all that up and minus away that, we will get the delta H value there. Same is true if the reaction is endothermic. So there's the endothermic reaction. Delta H is there. In this case, delta H is positive. We add up all the energy in order to break the bonds. We minus away all the energy released when we make the bonds, and that gives us that energy gap there, which is delta H. So if we go back to our reaction, which was H2 plus Cl2 going to make 2HCl, we talked about the fact that you got two hydrogens attached, you got two chlorines attached reacting together, and they're making HCl and another HCl. So we had to break these bonds, and then we had to make these bonds. But if we want to work out delta H, we do bond breaking minus bond making, so the energy that's needed to break those bonds minus the energy needed released when making those bonds, and we'll get the delta H value. Now in an exam you'll be given the values in order to break the bonds and make the bonds. So I'll find you an exam question now where they actually give you the values. So actually the one I managed to find was the exact same reaction as we're doing here, so I'll just show it to you. So it says the reaction between hydrogen and chlorine to give hydrogen chloride can be represented by the following equation. So we got hydrogen reacting with chlorine, those are the bonds we're going to break, and then we're going to make these bonds here, which makes hydrogen chloride. And then it says the relative amounts of energy needed to break the bonds shown are given in the table below. So to break the HH bond, we need 436 kilojoules. To break a Cl joined to a Cl, we need 242, and then for the HCl's, 431 kilojoules of energy. And it says, using the bond energy values in the table, calculate. Ultimately, by the end of it, is going to ask us to calculate delta H. So let's have a go at doing that. So, bond breaking. What is the total amount of energy required to break the bonds? If I leave this here. So, total amount of energy required to break a HH bond, 436. And to break a Cl-Cl bond, 242. So that's how much energy to break the bonds, which adds up to 678. And then bond making, how much energy is released when we make all these bonds? 431 plus 431. So two lots of 431, because we're making these two bonds, gives you 862. So delta H is going to be the energy for bond breaking, which is 678, and then we'll minus away the energy released when we make these new bonds. So 678 minus 862 gives you minus 184, and then don't forget your units, which are kilojoules. I know the units because they're the ones that they give me in the question, which are kilojoules. Now what I can do from that value is I can actually decide whether the reaction was exothermic or endothermic, and I can do that from the fact that this value is a negative value. So delta H is negative, meaning the products have less energy than the reactants, and so this reaction is an exothermic reaction. So if the value that comes out is negative, it's exothermic. If the value that comes out is positive, then it would be endothermic. We'll do maybe one more to practice. Let me just try and find one. So here's another question. So it says methane reacts with chlorine in the presence of sunlight. The equation for this reaction is shown there. So we're going to have to break those 4 bonds and that one, and then we're going to have to make these bonds there. So break these bonds on this side of the arrow and then make the bonds on the opposite side of the arrow, and they give us the bond energies there. And then the question says show that the enthalpy change or energy change delta H for this reaction is minus 103 kilojoules per mole. So they've actually told us that delta H is minus 103. Is more of a prove question, the type of questions you often get in maths, where you've got to prove that delta H in this case is minus 103 kilojoules per mole. So let me just think I'm going to set this up. Alright, hopefully with that you can see everything. So there's the reaction, those are the bond energies. We've got to show delta H is minus 103. So I'm going to rewrite the equation and I'm going to shorten it. So delta H is bond breaking minus bond making. So add up all the energy required to break the bonds and then minus away the energy that we release when we make the new bonds. So bond breaking, what bonds am I breaking? I'm breaking 1, 2, 3, 4 carbons joined to hydrogens. For every carbon joined to hydrogen is 413 kilojoules per mole. So 4 times 413 to break those 4 bonds. And I also need to break this chlorine to chlorine bond, which has 243. So now I've broken all of those bonds with those values there. So if I add them up, I get 1,895. And then bond making, in order to make these bonds over here, in order to make the carbon to hydrogen bonds, 413, and I'm making 1, 2, 3 carbon to hydrogen bonds, so 4 lots of 413, plus I'm making a carbon to chlorine bond, so carbon to chlorine 327, and then plus I'm making a hydrogen to chlorine bond, which is 432. So if I add up those values, I get 1,998. So final thing left to do, delta H is bond breaking, so 1895 minus bond making 1998. So 1895 gives me minus 103 kilojoules per mole. And that is a proof question, so I proved that that was the answer by showing my workings. This equation, you get given some equations in other subjects, but actually in chemistry you don't get given any equations, so this equation you need to learn. I showed you how to derive it in a previous video, but ultimately it's not that hard to learn. Bond breaking minus bond making.